So now what we're going to do is move on to polynomials of a degree 3 or higher that can't be factored. And so what we're going to do first is learn a process called long division, which is kind of the root of everything. And then we're going to learn a shortcut for this. So there's going to be questions that simply say solve by long division. So the first thing we're going to do is talk about the parts of a division statement. So when you look at a long division question, so this long division question was set up and solved for you, there is a part that's underneath the radical sign, sorry, not the radical sign, underneath the long division sign, and we call that the dividend. So the dividend, which is represented with a p of x, is the thing that you're dividing into. And then the thing that's doing the dividing, so the thing that's dividing in, is called the divisor, and it's going to be shown with a little d of x. And then the answer of the division question is the quotient, which is q of x, and then what's left over is called your remainder, or r of x. And the reason this is important is because what we're going to learn how to do is learn how to write division statements, because then it kind of makes sense why you're doing long division. So a division statement states that the dividend is equal to the divisor times the quotient plus the remainder. So if you look at this division statement, we can say that x cubed plus 2x squared minus 5x minus 6 is equal to x plus 1 times x squared plus x minus 6, and then the remainder is 0, so we don't need to add it on the end. And then you can kind of see that we're getting towards this place where we've factored our cubic function. And so the next part of this is to say, okay, well, when we divided by x plus 1, because the remainder was 0, was x plus 1 a factor? In other words, did it divide in, I call it, cleanly? And the answer is yes. When the remainder is 0, then the divisor is a factor of the dividend. So for this one, the answer is yes. When we look at this next question, so in this one, we took that same dividend, x cubed plus 2x squared minus 5x minus 6, but this time we divided by x minus 3. And we got a quotient of x squared plus 5x plus 10, but then we have this remainder of 24. First thing we're going to do is practice writing a division statement. So for this one, it's going to be that x cubed plus 2x squared minus 5x minus 6 is equal to that divisor, x minus 3, times the quotient, x squared plus 5x plus 10, plus the remainder of 24. So for this one, because my remainder was not 0, it means that x minus 3 did not divide cleanly into my dividend, meaning that x minus 3 is not a factor of the dividend. Okay. So now that we've looked at that, there's one thing I want to teach further before we actually go into the process of long division. And that's a way to kind of check to make sure that you've done your long division correctly. So there's kind of this shortcut of finding a remainder. If you think about what we've done here, we've said that this would factor to x plus 1 times x squared plus x minus 6. So if you think about what we were doing before, where we had linear factors and then we could solve the linear factors to be able to get the zeros, we would say that x equals -1 is a zero of this function. Because when we plug in x equals -1 into this dividend, or into this cubic function, we ended up with a y equal to 0. And what we were doing there without knowing it was actually finding the remainder of the division. So if we divided this by this, we got 0 as our remainder. And so that's our remainder theorem. The remainder theorem is that if you have a function f of x is equal to x minus c, so some divisor times some quotient plus a remainder, if you plug in the value of c into the original function, what will come out is the remainder. So let's just double check. So for the first one, we're saying that x equals -1. That's our value of c. That's our potential 0 of our function. So we're going to plug in x equals -1. And we end up with -1 cubed plus 2 times -1 squared minus 5 times negative 1 minus 6. And what we should really do is plug this all into a calculator. I don't have a calculator sitting beside me, so I'm going to go negative 1 plus 2 plus 5 minus 6, and I end up with 0. I get that remainder, which means if I take this one and I say, well, what we've been calling is a 0. So if we solve this, we'd say x is equal to 3. And so I'm going to then plug in x is 3. And up until now, we've been saying, okay, well, it's equal to 0. But now what we're doing is saying, well, what does it equal? So if we plug in 3, we end up with 3 cubed plus 2 times 3 squared minus 5 times 3 minus 6. Now for this one, I need to find a calculator. So I'm going to plug this in. I get 3 cubed is 27, plus 2 times 9 is 18, minus 5 times 3 is 15, minus 6. So I guess I did some mental math. And I end up with 24. And if you look back up here, the remainder, when we did the long division by x minus 3, we got 24. When we plugged x equals 3 into my function, I got 24. So it's just a quick way that if you do this whole long division to be like, oh, did I do this right? You can check that your remainder is correct. Okay, so now that we've done all of that checking, let's actually learn how to do long division. Now, it's going to be a approximately 6-step process, where step number 1 is to set up. We're going to set up our long division. So we're literally going to draw our long division sign, and we're going to put our dividend underneath. Now, this is my dividend. Here's the most important part. Now, I find with long division, you'll catch it, but when we go into the shortcuts called synthetic division, you won't catch it. So when you set up your dividend, you want to make sure that your x's go in descending orders of power. So for this one, I'm going to have x cubed minus 2x squared. And because it's missing the x term, I'm going to put in what I call a ghost term or a missing term. So I'm going to put in a 0x because 0x is actually not existent, but it's kind of like a placeholder. And then we've got minus 4. So double checking, I can see that my powers go 3, 2, 1, gone. And then I'm going to put in my divisor of x minus 3. Now, that is the setup. Now we can move on to the actual divide. So what I do to start is think about the fact that when you're doing long division, you're always trying to kind of reduce. When you're doing a long division of polynomials, what you're going to try to do is get rid of a term at a time. So every time you kind of do a process, you're going to get rid of the x cubed, then you're going to get rid of the squared, and then you're going to get rid of the x, and then you get rid of the constant. So you're dividing into sort of one term at a time, and yet there's 2 terms in your divisor. And so what we do is just let the second term come along for the ride. So when I say divide, you're going to divide the first term in the dividend by the first term in the divisor. So for this one, we're going to take the x cubed and we're going to divide it by the x, right? So the x cubed divided by the x, and we get x squared. And then we're going to take that x squared and you're going to write it above the matching term in the dividend. Then you're going to move to step 3, which is to multiply. We're going to take that x squared and we're actually going to multiply it by the x minus 3. That's going to give us x cubed minus 3x squared. So that now I can move on to step 4, which is simply to subtract. And why do I do this? Because now when I have x cubed and I take away x cubed, I'm down a term. And then I've got negative 2x squared, take away negative 3x squared. So some people like to change this to plus and plus just so it's easier to see. And we end up with plus 1x squared. And then we're going to bring down the missing term of 0x. And then we're just going to repeat this process. So we are going to go back to step 2 and we're going to divide. This time we're dividing the x squared by the x. That's going to leave me with just an x, and I'm going to take that and I'm going to write it above the matching term in the dividend. Then I'm going to multiply. And again, you're always multiplying by that divisor. That will give us x squared minus 3x, and then we subtract. Again, the whole point of this is that we're getting rid of the front term. So we've got x squared minus x squared is gone. And then we've got 0x take away 3x is going to leave me with a plus 3x. Then we're going to bring down. We're going to bring down that minus 4. And then we're going to repeat this process one more time. So we're going to take this 3x and we're going to divide it by the x, and we're going to end up with 3. Then we're going to multiply by the divisor. That will end up with 3x minus 9, and then I get to subtract. I've got 3x minus 3x is gone, I'm down a term, and then I've got negative 4 take away negative 9 is actually adding 9, and I'm going to end up with a remainder of 5. Now you'll notice here I forgot to put the 3 up here. I always forget to fill in my quotient. It's kind of why I like writing this on the side, because if I forget to write my quotient, I can be like, oh yeah, x squared, x, and 3. Okay, I'm good. So this is my completed long division. Now this question said use long division to find the quotient and the remainder when the dividend is divided by the divisor. And so I've done that. I can answer this by saying that my dividend, oh shoot, sorry. I hate it when I hit the blank space. My dividend, sorry, my quotient is x squared plus x plus 3. My remainder is 5. And then let's practice writing that division statement. So we're going to express the dividend in the form divisor times quotient plus remainder. So we've got divisor times quotient plus remainder. Now if I wanted to check this, I could just multiply out and make sure that this multiplies out to give me x cubed minus 2x squared minus 4, or we could also do a little check just to check to make sure we got the right remainder. So if I plug in, if my factor or my divisor is x minus 3, I'm going to be checking x equals positive 3. So I'm going to plug in f at 3. That's going to give me 3 cubed minus 2 times 3 squared minus 4. And if I plug that into a calculator, I'm hoping I get 5. So 27 minus 18 minus 4, 5. Okay, so that's the process. It's not easy. And usually in class I would start with an example where we do long division of numbers, just sort of to remember the process. But in here we just jump to it. So we're going to remember these steps. So we're going to remember setup, which is fine, but we're going to remember divide, multiply, subtract, bring down. My kids are learning long division in school, and they've got this little rhyme, or a little it's kind of like a song. They're like, divide, multiply, and subtract. Bring it on down and bring it on back. And so whenever I think of this, I always want to think that in my head. So if it helps you, you too could sing the division song. But I do find that if you can kind of even just write this down somewhere to cue yourself to what to do, I always remember I always forget the part to write it in the quotient. So sometimes I'll put a little T here, like don't forget to write it on top. So divide, multiply, and subtract. Bring it on down and bring it on back. Let's do another one. All right, so for this question, it's saying use long division, again, to find the quotient and the remainder when p of x is equal to blah, 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 and is divided by blah, blah, blah. And then again, we're going to express it as a division statement. So this is exactly the same as the one we just did. Now, if you're feeling ready to do it, go ahead and pause the video. If you're not feeling ready, let's do it together. So let's do the setup. I'm going to put my dividend underneath my division sign. So I've got x cubed minus 3x squared minus 13x plus 15 as my dividend. And then my divisor is x plus 3. This one, you just heard my stomach, I'm starving. For this one, do I have descending in orders of power? It goes 3, 2, 1, gone, so I'm good, and I get to start going. So again, if it helps you, you could write this at the top. Divide, write it up top, multiply, subtract, bring it on down, and bring it on back. So for this one, we're trying to turn x into x cubed. Now some people just they don't do the division step. They're like, what do I multiply x by to get x cubed? And they're like, it's x squared, and then they multiply from here. But I'm going to do the whole thing. So we're going to take the first term in my dividend. I'm going to divide it by the divisor, and I end up with x squared. I'm going to take that, I'm going to write it above the matching term, because then when I get to the end, I know I'm done. Then I'm going to take that quotient and I'm going to multiply it by the divisor. I end up with x cubed plus 3x squared. So I divided, I multiplied, and now I'm going to subtract. X cubed minus x cubed is gone. negative 3x squared minus 3x squared is negative 6x squared. And then I'm going to bring it on down. And then I'm going to repeat. I'm going to divide. I've got a negative 6x squared. I'm going to divide it by x. I end up with negative 6x. I'm going to write it up top, and then I'm going to multiply. I end up with negative 6x squared minus 18x, and then I'm going to subtract. Negative 6x squared plus 6x squared is gone. Negative 13x, take away negative 18x means I'm adding 18x, so I've got a 5x. Bring it on down. Then I'm going to divide. I'm going to take that 5x, I'm going to divide it by x and be left with 5. I'm going to take that and I'm going to write it up top. Then I'm going to multiply. I didn't forget a single one this time. Then I'm going to multiply and I end up with 5x, plus 15. This feels way more satisfying. And then I'm going to subtract. 5x minus 5x is 0, and then I'm left with 15 minus 15, which is 0. I get a remainder of 0. So now before I write my division statement, let's just do a quick check. So I'm going to plug in x is negative 3. I get negative 3 cubed minus 3 times negative 3 squared minus 13 times negative 3 plus 15. No point in doing all that work and getting it wrong. So that's going to give me negative 27. Minus 3 times 9 is 27, plus 13 times 3, or negative 13 times negative 3, plus 15. Yes, I get 0. So now I'm going to write my division statement. So I'm going to take my divisor, I'm going to multiply it by the quotient, and I'm going to add the remainder, which I don't need to do. Awesome. Hopefully you're feeling kind of good about this. We're going to do one more. Actually, I think there's 2 more. We're going to do 2 more because long division takes practice. So if you're feeling ready to fly, you can pause the video now and give it a go, or you can stay with me if you're not quite feeling ready yet. Now this question has changed a little bit. For the function f of x is equal to 4x squared plus 3x squared minus 7x, use long division to determine if the following is a factor. So what we're going to do is we're going to set this up. This is going to be my dividend. Now this one, when I look at it, I can see there's missing terms. I'm missing an x cubed and I'm missing a constant. So I'm going to write this as 4x to the 4. Oh, that doesn't look like a 4, does it? Plus 0x cubed plus 3x squared minus 7x plus 0 is being divided by x minus 1. Okay, so this one I did as a quartic function. So all this is that it's one more step. So there's going to be one more process of divide, multiply, subtract. But it starts out the same. You're going to take the first term in the dividend and divide it by the first term in the divisor. That's going to give me 4x cubed. I'm going to take that and I'm going to write it up top. Then I'm going to multiply the quotient by the divisor, and I'm going to end up with 4x to the 4 minus 4x cubed, and then I'm going to subtract. 4x to the 4 minus 4x to the 4 is gone, and then I've got 0x cubed. Take away 4x cubed is going to leave me with positive 4x cubed, and then I'm going to bring down the next term. And then I get to start the process again. So I'm going to take the first term in my new dividend. So I'm now dividing these 2 terms by these 2 terms. And I get 4x cubed divided by x gives me 4x squared. Write it up top. I feel like I started out this video really excited and I've calmed down. Sorry if I went really fast. So now I'm going to take that 4x squared, I'm going to multiply it by the divisor, and I end up with 4x cubed minus 4x squared, and I'm going to subtract. 4x cubed, take away 4x cubed is gone, and then I've got 3x squared, take away negative 4x squared, which will give me 7x squared. Bring it on down. Start the process again. So now we've got 7x squared, which we're dividing by the x again, and we end up with 7x. we're going to write it up top. Then we're going to take that 7x and we're going to multiply it by x minus 1. We end up with 7x squared, minus 7x. And then I'm going to subtract. 7x squared minus 7x squared is gone. Then I've got negative 7, take away negative 7, which is going to end up with nothing. And then I'm going to bring down the next term, which is a 0. So if I took 0 and I divided it by x, I would end up with 0. So I'm just going to put a 0 up here, which you don't even have to write. Okay, so whether you do or don't, it actually doesn't really matter. It doesn't count. So we're at the end. And so because my remainder was 0, what does that mean? So since, upside down therefore statement is a since my remainder is 0, therefore x minus 1 is a factor. Awesome. All right, we have one more. So same dividend, but this time we're going to divide by x plus 2. So hopefully at this point you feel confident if I leave you, or not leave you, but if you pause the video and do this one using long division. And then if you're not feeling confident or after you finish, you can always check. Now I didn't check this one, right? So I could do a quick check, right? If I wanted to check, I could plug in f at 1 into the dividend. So I would have 4 times 1 to the 4 plus 3 times 1 squared minus 7 times 1, which would give me 4 plus 3 is 7 minus 7 is 0. So yeah, I'm good. So really, wouldn't you use the remainder theorem to determine if it's a factor? Heck yeah, we will going forwards. But for now, we're just learning this process of long division. Because Math 60 likes you to know the root of everything, and long division is the root of everything. All right, so pause the video, give this one a go. All right, so first we're going to set it up. I've got my dividend. I'm trying to use these words over and over again. I'm not. Oops. Don't talk and write at the same time. Missing ghost term. And this time we're dividing by x plus 2. Okay, so again, first term in the dividend divided by the first term in the divisor. I've got 4x to the 4 divided by x, which is going to give me 4x cubed, and I'm going to write it up top. Then I'm going to multiply that by the divisor, and I end up with 4x to the 4 plus 8x cubed, and then I'm going to subtract. I end up with negative 8x cubed. Then I'm going to bring it on down. And then I'm going to divide. Negative 8x cubed divided by x is negative 8x squared. And then I'm going to multiply. I end up with negative 8x cubed minus 16x squared. And then I'm going to subtract. The first term goes away. I'm left with 3, take away negative 16. So 3 plus 16 is 19. If you can't tell already, that's the #1 place people make mistakes with long division is integers. Then we're going to take, oh, look, I already forgot. I was doing pretty good there. And then I'm going to take this 19x squared and I'm going to divide it by x. I end up with 19x. Blah, this number's getting big. Then we're going to multiply. We end up with 19x squared plus 38x, and then we're going to subtract. 19x squared minus 19x squared is gone. Negative 7x, take away 38x is going to be negative 45x. I feel like my brain's getting tired. And then we're going to bring it on down. Then we're going to take that negative 45x and divide it by x. We end up with negative 45. We're going to multiply it by the divisor, and I realize I've forgotten to write my quotient. I'm just going to do it at the end. We end up with negative 45x minus 90. Then I'm going to subtract. We end up with negative 45 plus 45 is gone. 0 take away negative 90 is going to be 90. Now again, like I said, I forgot to fill in my quotient, but this is going to save me. 4x cubed minus 8x squared plus 19x minus 45 is my quotient. Now they didn't even ask me what my quotient is. They just wanted me to use long division to determine if x plus 2 is a factor. And since the remainder is not equal to 0, Therefore, x plus 2 is not a factor. Now I feel like before I end this video, I should actually make sure I didn't make a silly mistake. So let's just check. So we're going to plug in -2 for x and see what we get as our remainder. So we've got 4 times -2 to the 4 plus 3 plus 3 times -2 squared minus 7 times -2. And we're really hoping we get 90. So I'm just going to plug this in. 4 times -2 to the 4 plus 3 times -2 squared minus 7 times -2. Whew, 90. Really be awful to have to film this whole video again because I make a mistake. All right, so that's long division. You know, it can be a thing. If you don't understand the way I did it, I'm sure there's lots of videos on YouTube that you could find. Just type in long division of polynomials and somebody else will describe it. But honestly, when when my kids came home and taught me divide, multiply, and subtract, bring it on down and bring it on back, I swear it made the whole thing better. So you just have to remember what you're dividing. So you're dividing the first term by the first term, and then you're multiplying by that divisor, and then you're subtracting your two terms, and it'll always be 2, right? Your divisor will always be 2 terms for us. And then you're going to subtract and then bring on the next terms, because you always need 2 terms to divide into, right? So we can't divide into all 5 terms at once because we're dividing by 2 terms, so we divide 2 terms at a time, getting rid of a term one at a time. Awesome. Good luck.